Good morning, everyone. My name is Susan, and I am a chemistry faculty. Today we are going to read reaction mechanism of organic chemistry. In that, first we have to know that there are some reaction mechanism for organic chemistry. For organic chemistry. Now, what do you mean by reaction mechanism? There is a mechanism of everything. Whatever work we do, it has a mechanism. Anything which has a procedure is known as its mechanism. So, in same way, organic chemistry reactions, organic reactions occurs in a particular way. So, there are different types of organic reactions. For example, nucleophilic substitution reaction or nucleophilic elimination reaction, electrophilic substitution reaction, electrophilic elimination reaction. So basically there are many types of reaction mechanism available. So today we are going to read about nucleophilic substitution reaction. Nucleophilic substitution reaction. So basically we are seeing there are three terms. There are three different terms associated with it. First is nucleophilic. Now what do we mean by nucleophilic? If we can differentiate the word, it will be consisted of nucleo plus philic. Nucleo plus philic. What do you mean by nucleo? It somehow seems to be coming from a word which means nucleus. Now we all know that what is nucleus. So in the structure of atom chapter, we have already learned that there will be a nucleus present at the center of the atom, and there will be different orbitals surrounding it in which electrons will rotate. So basically these are the places where electrons will rotate, and protons and neutrons will be available in this particular area, which is also known as nucleus. We also know that proton has a positive charge, and neutron has zero charge. Similarly, that particular electron has negative charge. So if we are considering only nucleus, then whatever charge we get, we have a zero charge and we have a positive charge. So we can say that nucleus is a positive charged entity. It means it is completely, we can say that it is completely positively charged. So basically we can say that nucleus is a positive charge entity. It contains positive charge. Now here is the second term, that is philic. We have already learned that there are two terms. One is philic and other one is phobic. Phobic, we have already learned so many times that phobic is related with fear. Fear, that means dar lagna. And philic is loving, caring. So we can now see that nucleus loving. It means nucleophilic or nucleophile. We can also get a new word, nucleophile, which can be written in short form as Nu. Minus charge we have put over here. We will see why I have put in minus charge over there. So basically, this is an entity, this is a particle which loves nucleus, and nucleus is a positive charge, and we also know that like charges repel each other and unlike charges attract each other. It means whatever this particle must contain negative charge, because it loves a positive charge. So nucleophile will always a negative charge entity. So we have understand that what is a nucleophile or nucleophilic thing represent. Now what is substitution? Now we also take an example, substitution. Substitution means we have already seen various matches, cricket matches, in which a player gets retired hurt, or he if he or she gets tired, he goes out of the stadium or he goes out of the ground for some time. And a different player of the playing 11 or playing 12 comes in replacement of him for quite some time, or for the rest of the match. So basically substitution is replacing someone, eliminating someone. Elimination means just to move him out of the ground and replacing someone other. So substitution means to substitute. Let's for example, take for example, here. For example, let me make a carbon chain. For example, this is a carbon chain, and here we have put a halide, that is halogen. It might contain chlorine, bromine, iodine, or fluorine, and here is something called H, and also there is a nucleophile Nu minus. For our study purposes, let's take here a OH minus group. Now, what is substitution? Substitution means taking out this particular halide from this alkyl halide. Now, I have taken a new word, alkyl halide. We will see in some time what is alkyl halide. We will replace this halogen atom from this particular carbon chain and substitute OH minus here and substitute OH minus here. So this example will look like this. And here we will get a X minus ion separate from this particular alkyl halide. Now it has become a alcohol. So here we can see alcohol has replaced this halogen in this particular scene. So substitution means something going out and somebody takes its place. Now what is reaction? Reaction, we all know that from 7th class we are learning or we are studying about reactions, chemical reactions in which reactants participate and forms a new product. So basically, what do we mean by nucleophilic substitution? It means substituting something in a chemical reaction, where nucleophiles are involved. So this is all about nucleophilic substitution reaction. Now we have to understand or we have to learn about its type. I guess we have taken the notes carefully. Let's erase this. Now, types of nucleophilic substitution reaction. Nucleophilic substitution reaction. What are its types? There are two types. First one is SN1 reaction and another one is SN2 reaction. Now, this is the short form of something. So, what is this? S stands for obviously substitution. We have already learned what is substitution. N stands for nucleophilic. Now here also S stands for substitution, N stands for nucleophilic. Now what is this 1 and 2 stands or represents here? 1 and 2. This is molecularity. Now what is molecularity? As we have studied chemical kinetics and we have learned about molecularity in that chapter, that molecularity is the number of molecules associated in the very first step of a chemical reaction. How many molecules are attracted or how many molecules have taken part in the chemical reaction in very first step. So if there are two different types of molecules present in a chemical reaction, but only one of that has taken part in very first or initial reaction, the molecularity of that reaction will be 1. And we also know that 1 can be written as uni. So this will be known as unimolecular reaction. SN2, 2 means bi molecular reaction. Now, what does 2 mean? It means we do have two different type of molecules present in that chemical reaction, and both of them has taken part initially on the very first step, uh, and gave product. So basically, let's take an example. Let's take an example of both this situation. Here, we can make A to B. Here, only one molecule is present, so its molecularity will be 1. Let's take another example. For example, we have taken A plus B and it's giving C. Now, I am saying that it is a multi-step chemical reaction. Multi-step chemical reaction means the reaction is going to happen in different steps. First step, in the very first step, only a particular molecule is taking part, not this one. This one, no. Only this is taking part initially. So we will say molecularity of this particular reaction is again 1. Now coming to this one, if we are saying A plus B is going to make C. Now I am saying that this is also participating in the chemical reaction, this is also participating in the chemical reaction, and product is formed with the participation of both these two entities. So in the very first step, both of them are involved. So we can say that molecularity of that particular reaction is bimolecular or 2. So we have understand what does this stands for. What does this stand for? Now we will learn about each one separately. Now we are going to read about SN1 reaction. SN1 reaction or mechanism. SN1 reaction or mechanism. Let's make something. Let's make a alkyl halide. I am saying this is a alkyl halide. What does it mean? This is a alkyl. Alkyl. We already know from hydrocarbon chapter, a alkane. A alkane from which a hydrogen is removed will be termed as alkyl. And in respect of that hydrogen, we have added a halogen over here, a halide over here, which can be fluorine, chlorine, bromine or iodine. So this total will be known as alkyl halide. We have to learn this alkyl halide in detail in our haloalkane and haloarene chapter, which is the very first chapter of organic chemistry in class 12. So alkyl halide, and we are also taking a nucleophile in this particular situation. As we are studying SN1 reaction, that means a nucleophile is a mandatory or is a must. Now it will be a multi-step reaction. Multi-step reaction. Step 1. What will happen in step 1? Now, look. First, this which is an electronegative element, will take electrons shared between carbon and halogen, will take it away and remove from here on its own. So basically, what will it look like? It will look something like this. That will be a X minus, and this will be a carbocation. Now, we also know that from hydrocarbon chapter from last year, that stability of carbocation. Now, what is carbocation? Carbocation is a positive charge on a particular carbon. So, stability of carbocation is 3 degree greater than 2 degree greater than 1 degree greater than CH3 plus. It means 3 degree carbocation will be more stable than 2 degree, then 1 degree, and least stable will be methyl. Okay? So basically what we are seeing here over here, this is a 1 degree carbocation, this is a 2nd degree carbocation. So basically we all know that there will be a hydride or methyl shift. If possibility of rearrangement is there, In this case, we are seeing that it's a 1 degree carbocation which is less stable than 2 degree carbocation, and if there is a hydrogen present over there, this hydrogen will shift to this atom, this carbon atom, and this plus charge will be shifted to this, and it will look like something like this, and it will be more stable. This one will be more stable than this particular, which was earlier a 1 degree carbocation, because this is a 2 degree carbocation. Now, we also know that in that particular solution or in that particular chemical reaction, there was a nucleophile which contains a negative charge, and here we see that there is a positive charge over here. So basically what will happen, this nucleophile will come and get attracted towards positive charge, and it will make a product like this. This will be a nucleophile. This will be a nucleophile. So overall, my product will be that one. We have started from here, and my product is this. So we can also say that this X minus has been substituted by this nucleophile. This X minus has been substituted by this nucleophile. Let's take another example to make you understand more better. Let's say take a 3 degree carbocation. This is a 3 degree carbocation, and this is a halide added on it, so we will say this is a alkyl halide. So it will go from here like this, and we have a nucleophile also present in this. And for example, we will take it's a OH nucleophile. Now, in very first step, it will remove from here, and it will make a carbocation of 3 degree. And we have earlier seen that 3 degree carbocation is a much more stable entity. Okay? So basically, what is going to be happen here? It's a 3 degree carbocation which is stable, and X has been replaced out, or X has been removed out from here. But we do have a nucleophile. We do have a nucleophile which has a negative charge. It will get attracted towards carbon, and it will form a compound something like this. Something like this. So now we can analyze something from here, that in very first step 1, what is happening? Formation of carbocation is happening. Formation of carbocation is taking place. Formation of carbocation is taking place. And second step 2, addition of nucleophile. Addition of nucleophile takes place in the very second place. Addition of nucleophile is taking place. First thing. Second thing, we can see that this is the exact position. This is the exact position where nucleophile has attached, where it was earlier a halogen. So we can also say that it has retained its position. My position has been retained. Earlier I was standing here, I moved out, and you come here, but stand on this particular position. So basically, we can say that someone has retained my space. So we can also say that it has retained its place. Another thing, it's a two-step process. It's a two-step process, multi-step process. Another thing, we can also say that, let's make a point chart. First, it's a unimolecular process. Unimolecular process. Why I am saying unimolecular process? Because in very first step, only carbon, the carbocation formation is happening, not the addition or not the substitution of nucleophile. It's in the second step. So basically, first step is the formation of carbocation. So it's a unimolecular process. So rate. Now what is rate? Also in chemical kinetics chapter, we have learned about rate of chemical reactions. We know that there are different order of rates. For first order, we have 0 order or second order reaction. So the rate of the reaction here will be directly proportional to substrate only. Substrate is what here? Here substrate is alkyl halide. Alkyl halide will be the substrate because it is the one who is taking part in the chemical reaction at very first instance, not the nucleophile. Nucleophile is not taking part in this reaction at first step, and we know that first step for this reaction will be rate determining state Q. Why? Because it's a slow step. So rate will be directly proportional to substrate. Now we have also seen that it will retain its position, retention. It will retain its position, but we need to see one more thing. Let's take the same example. Now again, X has been excluded out from here and a carbocation is formed. Now nucleophile. Nucleophile can get attracted to this carbon from this side or may get attracted from this carbon at this carbon from this side. So there will be a mixture of product which might contain this thing or this thing, either this or this. We can say it is the retention and we can say it is the inversion. So basically we will see a mixture which has retained product as well as inverted or inversion product. That will be a racemic mixture, not 100%, but it will somehow a racemic mixture. Now what is racemic mixture? A mixture in which we have two different groups of isomers present. One will be D, dextrorotatory, and one will be L. So retention and inversion is also taking place here. Now these are some points of SN1 reaction. Now we are going to SN2 reaction mechanism. SN2 reaction mechanism. Let's take an example. Let's take an example of the earlier alkyl halide group. Sorry, here it will be X. Here it will be X. Alkyl halide we have taken. Now we will also take a nucleophile. Now in this case, earlier in the SN1 case, we have seen that carbocation formation will be the first step. Now here it will not happen because nucleophile can be termed as good as well as bad. I am saying just for example bad or good. It can be also rich or poor. We can also say that it's a rich or poor depending upon the concentration of nucleophile. So basically there in the very first SN1 mechanism, it was a poor nucleophile or it was a bad nucleophile. It means the charge density on that particular nucleophile was somewhat less. But here it's a good nucleophile. It means this charge density is very much larger. Now what will happen in this particular scenario? Here this carbon, this halide will take electron cloud from center and move towards itself. Moving it towards itself will develop a partial negative charge on it and a partial positive charge on this. So basically we can represent as a dotted line like X, delta minus and delta plus. Now we have represented a dotted line. It means it is just pulling out and going away from this carbon. It is just pulling out the electrons shared between these two atoms and going out from this carbon. Now we also know that we have a nucleophile present in the system. This will see it has a larger charge density. It will see there is a vacancy or there is a charge, positive charge entity present in this. So what it will do? It will come from backside and gets attracted towards it. Why backside? Because it's already a negative entity and it's also a negative charge entity. Both negative might get repelled. So it will not come from this or this side. It will not come from this or this side. So basically it will take the backward side because there will be no repulsion. So now in this system, what will happen? This X will get away and this nucleophile will get attracted. So basically what we can say, this is a bond breaking scenario. Here bond is breaking and here bond is formed. Bond is formed. Now here let's count the number of carbon bonds. First, second, third, fourth, fifth, and we know that carbon is a tetravalent compound, so it can only contain 4 different carbon bonds. So it will not have a 5 carbon bond. So this 6 will get away from here or dissociate away from here, and it will look something like this. It will look something like this, and nucleophile will get substituted on it and X will be repelled out. Now you will say, sir, this is something of similar sort, but just what is the difference? Before that, let me teach another scenario. States. First is transition state, and another one is intermediate formation. What is this? Let's take a very crude example to understand this. Let's take an example. If a train is going from Kota to Jaipur. Its starting point is Kota and its end point is Jaipur. For example, this is the reactant and this will be the product. Now, it has to pass different stations coming out on this track or in this route, but it will not stop at any station. It means a super fast express. It will not stop at any station. So there will be no formation of anything. So it will just pass through different stations. Similarly, in SN2 reaction, we have seen that the reaction was like this, in which a halide was getting away and a nucleophile was getting attracted. So a bond formation and a bond breaking and a bond formation was taking place simultaneously. There was nothing which was made between this reaction. So it will be termed as a transition state. Now intermediate formation, what do you mean by intermediate? Let's take another example in which a train is going from Kota to Jaipur and it stops at, let's say, Bundi. So basically what is happening, train will get stopped at Bundi for quite some time. Let's take for 2 minutes, train has stopped. So we can relate it with SN1 mechanism. Reactant makes product, but in between we have seen that it was a multi-step reaction. So in between there was a formation of carbocation. Carbocation was formed in between the reaction and on which nucleophile gets attracted. So basically carbocation formation is a intermediate state. It is a state where intermediate has formed. So these are some basic things about SN2 reaction or SN1 reaction. Now some points for SN2 reaction. First, we know that both of the alkyl halide or nucleophile gets attracted towards each other or gets repelled from the alkyl part in a very particular, in the very first step. So we can say that it is a bimolecular reaction. Second thing, we can also say that rate will be directly proportional to the substrate. What is substrate here? Exactly, alkyl halide is the substrate, and also on the nucleophile. It will also depend on nucleophile. Now, third point. Before third point, let me tell you, let me just make that example once again. This is a nucleophile and there was a halide associated here. So basically what happened, nucleophile take the back place, back side entry. So always there will be retention, there will be a inversion happen. Inversion process will happen, not retention. So it is an inversion process. Ascent mechanism is an inversion process. We also know that that it will depend on the strength of nucleophile. Whatever will be the strength, whose strength will be a greater nucleophilic strength entity will get attracted earlier. So these are some of the points with associated with SN1 and SN2 reaction. We will discuss about its example in the very next lecture. Thank you very much.